Hello and welcome to today's webinar. My name is Tyler Reed. I'm the Manufacturing Application Manager here at GoEngineer, and today's webinar is an exciting one for me to present to you guys. We're launching our essentially first contest of this kind, and we're partnering with some awesome people at Desktop Metal and Solid Thinking and Stratasys to bring you guys this challenge. We're calling it the Generative Design Challenge. And this is going to be the first video of many over the next 2 months while we run this challenge. Today we're going to introduce the concept, we're going to tell you how to get signed up, and we're going to give you a brief overview of the Solid Thinking Inspire Unlimited product that the challenge will be hosted on. We're going to give you a brief description of bound metal deposition, Desktop Metal's studio system, prototyping focused 3D metal printing, and also Stratasys FDM high performance plastic printing. I am presenting live from Boston, Desktop Metal's headquarters, and next to me is Megan Rock.
Hi, I am the Applications Manager here at Desktop Metal. So I will be presenting to you a little bit of the background of the technology and some details about our process and materials.
Awesome. Thanks, Megan. And on the line with us is Sean Kroger from Solid Thinking.
Hi, Tyler. Thanks. I'm the Director of Partner Sales for Solid Thinking, and I'm going to review with you the Inspire Unlimited platform and how to submit your challenges or your designs as you progress through the challenge.
Great. So let's jump into it. The concept of this challenge is kind of a recognition of where additive manufacturing is taking us and how it's transforming the way we create parts. We're creating physical parts through 3D printing now, and we're doing it in very high-performing plastics. And the metal printing is becoming more and more affordable, especially now once Desktop Metal hits the market here very quickly. And in order to make that, most effective, we have to design for additive. Our parts should be designed for their method of manufacture. If you're going to machine a part, that has its own set of design rules. If you're going to injection mold a part, it also has its own set of design rules. And the same thing applies to additive manufacturing. And those rules are a little bit different if we're printing on the DM Studio machine versus the Fortis production machine. And that's what we're hoping and asking people to, learn with us is how to use these tools to design for additive. So the Generative Design Challenge, we are using this landing page, www.goengineer.com/design challenge, as the main landing page for the contest. This is where you're going to find all the rules, the requirements. It's going to list the prizes, and it's also going to contain the sign-up form to get started. This is the first of many updates, like I mentioned. We plan on uploading at least once a week, a blog post or a video, giving more insights on the Inspire product, some suggestions on how you might set up studies. We're also going to go into more detail on the bound metal deposition technology and the Stratasys FDM technology. So we'll take a quick look at that landing page in a bit here. As I mentioned, we are partnering with Solid Thinking, Desktop Metal, and Stratasys in this challenge, and they have graciously sponsored some awesome prizes for the different categories. And when we look at the landing page, we'll kind of go over those. This challenge is being hosted on the Inspire Unlimited platform. It's a very powerful cloud-based generative design platform. The fact that you guys won't have to download anything to get started, and there's plenty of tutorials to help you get started, I think it's really going to impress you. If you've never used generative design at all, or topology optimization or anything like that, don't fret. A new user with a little bit of CAD experience is going to be able to create and submit a part, honestly, within an hour, if you'd like to. So let's take a quick look at the landing page. This is goengineer.com/design challenge, and this is where we are listing the categories and the rules and whatnot. You can see we have a category for metal. The idea here is that as you design a part within Inspire, you're going to want to size it a certain way. You're going to want to design it for its method of manufacture. And if the final part you want in metal, you're going to follow the design guidelines for metal. There's a link here. If we click this, it's going to take us to a brief design guideline for bound metal deposition. I will say bound metal deposition is an emerging technology. It's new. I created this design guideline from my very limited experience. And so the numbers that we are offering are conservative, and they don't necessarily reflect the capabilities of the studio system. They reflect what we're comfortable with for the design challenge. So we talk about things like layer thickness, minimum feature size. Wall thickness is an important concept with the BMD technology. Support structures, we want to make sure that people are aware that supports can be created. They're hand separable, which means they're nearly as easy to use as the soluble support we're used to on the plastic side. Things like this. So some basic general guidelines. We might offer more details as the challenge progresses, but this is a good starting point. Back to the landing page here, we also have a design guideline for those of you who are interested in designing parts for the Ultim 1010 plastic material. This design guideline is provided by Stratasys, and it is not specific to Ultim 1010. It's more general use case scenarios for FDM, but it does give you some good data. I will say right away, FDM Ultim 1010 only prints in 10,000 slice height, and it has breakaway support. So those are some things to keep in mind. FDM is a much older technology. There's a lot more info readily available on designing parts for FDM. So you should have no problem finding data, and you can always email me, treed@goengineer.com, if you have questions about that. So the idea is that if you enter into the metal or the polymer category, then the prize for the top 3 entries to each category is actually having your part printed and delivered to you. This is awesome. It's the most exciting thing about this challenge in my mind, and that is desktop metal, you can't get a part right now. This is the first time that the public has actually had a chance to design for the desktop metal system, and it's their first opportunity to really get a part in their hands, and that's really exciting. Now, the grand prize, sponsored by Solid Thinking, is a 1-year license to Inspire Structures, and there are 3 Inspire plugins: motion, stamping, and casting. So as you start to use Inspire Unlimited and you start to get hooked, well, you're going to have a chance to win a 1-year license, which is awesome. And I'm so happy that Solid Thinking was willing to front that. The 3 of us on the webinar today, myself, Sean, and Megan, we are the judges and the jury, and you got to impress us to win. Going down, we talk about the challenge, we talk about the reasoning behind the challenge, and then you'll find some requirements and rules as to what a submission's going to look like. And Sean's going to go a little bit over that in more detail. But the general idea is that you're going to submit it through Inspire Unlimited. It's going to be 3D printable for whatever category you are offering. And lastly, we really want to see novel, real-life applications. That's what everybody wants out of this, is we want you to kind of take a challenge that you're confronted with and find a solution for it. And we're just kind of, offering a little encouragement to do that. This contest starts today and it runs through the end of March. The winners will be announced in late April, and everybody the winners should have their prizes in hand, sometime shortly after that. If you're interested in joining, this is going to be the form that you fill out. We just need some basic information. Once you fill this form out, it's going to shoot you over to the Inspire Unlimited platform where you create an account there and get started. So that's it for the landing page. There is an update section. We don't have anything there yet, but again, weekly, hopefully we're going to have some more info for you that it's going to be very educational and something you want to maybe check out if you're participating in the challenge or not. So we're going to jump back over to the slide deck. And I'm going to give a brief overview to topology optimization or generative design, and then I'm going to swing it over to Sean, and he's going to show you the Inspire Unlimited platform. If you're not familiar with topology optimization or generative design, or some people will call it morphogenesis or biomimicry, the ideas are all the same. It's considered true design for additive manufacturing. We're using algorithms to solve problems, and the engineers, instead of designing the specific shapes that we want, we're defining boundary conditions, the largest envelope possible. We are creating what are called load scenarios. We're inputting, supports and forces and pressures, and essentially setting up the situation that our part is expected to endure. And then these, kind of nature-inspired algorithms whittle down the shape. They're showing you the load paths and eliminating that first guess that all designers and engineers have to take when they're confronted with a design question. And by eliminating that first guess and setting us down the correct path from the get-go, our design process is faster, it's smarter, we end up with lighter parts, or we end up with stronger parts for the same weight. Inspire specifically allows us to optimize our shapes for different characteristics. We can optimize for the stiffest shape possible. We can target a certain mass. We can avoid resonant frequencies, and we can also target for wall thickness. Another unique thing for Inspire is that we can create shape controls that allow us to not only use these topology optimization algorithms for 3D printing, which tend to deliver very organic shapes, but we can also guide our results to something that is usable for machining or casting or molding. That's one of the best things about Inspire in my mind, and one of the, kind of roadblocks to using topology optimization in the past is that we would end up with shapes that weren't manufacturable. That's changing a little bit as 3D printing becomes more of a reality, but as it stands right now, most production parts are still being machined or cast or molded. And topology optimization and Inspire is going to still be applicable there. So I'm going to kick it over to Sean here.
Excellent. So after you've signed up for the design challenge, you'll be headed to the Solid Thinking Inspire Unlimited website. And this is our main landing page for this. One of the things I want to point out right away is this resource section. So immediately, if you want to get some training, click on Inspire Training. That's going to take you directly to a self-paced training program so you can walk through with the Inspire Unlimited platform. Once you've signed up, you'll get to this login page, and the reason you sign up again is we have it set up so you can actually just use your social media profiles to directly connect with Inspire Unlimited. So, for example, I can just use LinkedIn, and it's going to recognize me and open up Inspire Unlimited. If you don't have a social media profile, just fill out your email, and you'll get an email verification. Just accept that, and it will set up an account for you on Inspire Unlimited. Now, once you're in the Inspire Unlimited platform, there's really two modes for Inspire Unlimited. The first is what we call viewing mode, where you're essentially just looking at models. And then the second mode would be actually editing mode, where you're creating and modifying designs. So similar to the topology optimization workflow that you see in the desktop version, you can either start with a brand new model, so you want to start from scratch, or you can upload an existing design. So for example, say I want to just upload a Parasolid file. That's going to be processed in Inspire, and it'll tell me when that model is ready to view. And here I can see, okay, I just uploaded this bracket. And from here, you'll notice in the right-hand side, you can view that model, edit that model, or delete that model. So say you want to edit that, you're going to actually launch a full version of Inspire on the cloud. So here we can see that model is opened up inside of Inspire. The same mouse controls allow me to move things as I would on the desktop version. And I can use all the tools inside of Inspire to create things like packaging spaces, Say I want to simplify fillets, for example. Very easy to come in and directly inside of the interface, start simplifying your geometry to make it more suitable, give it more boundaries so that you can come up with a new optimized design. I've already got one set up here, so I'm going to go ahead and leave this editing session and just open the one that I've already configured here. So you can kind of see what it looks like in the Inspire Unlimited interface. Now, you'll notice this splash screen comes up, and normally it loads fairly quickly. If for some reason it's taking a long time, just be patient, as sometimes we have to spin up a new instance. So it could take up to 12 minutes to actually launch that editing session if you happen to be the person that comes on and enters and creates a new instance. So here I've taken the original bracket design, expanded that volume, and let Inspire use the loads and the forces that this bracket's going to see to create a optimized shape. And so from this shape, you can directly start creating geometry using things like polynerves to simply, wrap the geometry with smooth organic shapes. Now, once you're happy with your design and you're ready to submit that to the judging panel, I want to point out here, you'll notice up at the top, I've got my account information. So if I go to my account, go ahead and leave my editing session, and we've set up a team, right? So we've got the GoEngineer Generative Design Challenge team. And once you've logged into Inspire Unlimited, you'll be added to this team. And you can then, with that, share any of your models once you're ready. So, say I wanted to take this final bracket design that I've created here and share that. You can come in and just share by user. So I could share this, say, with Tyler. And I can make Tyler either a viewer, an editor, or an owner. For final judging, you want to make Tyler, myself, and Megan a editor so that we can actually download and look at the model in details. If you want to just let other people look at your design without being able to change it at all, you could actually share it with the whole team. So you could say, I want to share this with the GoEngineer Generative Design Challenge team, and I want to let them view it. So this adds permissions to your designs to let others look at it. Also, if you want to ask questions, you can always use the Inspire Unlimited platform to provide feedback. So feedback is going to send your questions directly to the Inspire Unlimited development team, or you can actually messaging capabilities in here as well. So if I come back to messages, for example, I can send a message directly to Tyler. Check my model out. Right, and then that's going to go directly to Tyler. So this is also a platform that allows you to quickly collaborate, not only with the judges, but with others if you wanted to work together on a design. And as far as design or model types, when it comes to uploading models, Inspire supports all sorts of different file formats. If I look at the desktop version here, and I go to open a file, you can see that we support pretty much any type of design file from ACES, CATIA V4 and V5, IGES, Inventor, Parasolid, SOLIDWORKS, STEP, STL. Any of these model types can also be uploaded to Inspire Unlimited. The last thing I'll leave you with is that if for some reason you've got poor internet connection or you're unable to use the Inspire Unlimited platform, you are welcome to also use a free trial version of Inspire to set up and run your model, and then just upload your final model when you're ready to submit it to the judges. So if you go to go to request a trial under downloads. You can fill in that select Inspire from your drop down here, and we'll actually send you a license file for you to run a full desktop version of Inspire on your local computer. So that is an option if you're unable to leverage the cloud platform. So with that, I'm going to pass it back over to Tyler to talk a little more about the printing technology being used.
Awesome. Thanks, Sean. So just to reiterate to you guys, that wasn't meant to be a comprehensive look at Inspire. The tutorial that Sean linked to is going to be a great place to start. It's going to get you guys familiar with some of the CAD capabilities of Inspire, and then also how to set up load conditions and run optimization, and also play with the polyNURBS tool. And we are going to be talking about some more specific workflows that you might have. Say if you want to redesign an existing part, or if you want to start some basic shapes in SOLIDWORKS or your other CAD tool and then import those basic shapes into Inspire for the optimization. We're going to help you guys do that as well. So we're going to jump over back up to the slide, and Megan is going to give us a rundown on the DM Studio system technology.
Thank you, Tyler. So here we have the Desktop Metal Studio printer. This printer utilizes a technology called BMD, or bound metal deposition. This technology is similar to FDM in that it is a deposition process, 3D printing, and it also utilizes MIM technology. So similar to FDM, where you have a spool of plastic filament that's being extruded and printing apart layer by layer. We have a very similar process, except instead of the spool, we're using a rod, and that rod is made of powdered metal mixed with polymer and wax binders, which is then extruded onto the build platform. And later, there's another slide where we actually talk about the other steps in the process, but is later consolidated into a printed metal part. So the build volume is 12 by 8 by 8 inches, but you can see that the maximum part size is a bit smaller than that. And that's because we are printing with these binders, and when these binders are removed and the part sinters down, we lose some of the overall volume of the part. So we scale the parts up about 20% to compensate for that loss. The Z height, the smallest resolution we can do is 2/1000 of an inch, or 50 micron layers. And that's utilizing a 16th inch or 0.4 millimeter diameter nozzle. And perhaps one of the most interesting things about the Studio system, aside from the ease of use and, the office friendly capabilities, is the patented ceramic interface layer, which allows us to have hand separable supports. So what that means is we're printing our support structures out of metal. And then on top of that, right before we print the part itself, we print a ceramic interface layer. And when this part then sinters, that ceramic becomes a dust and essentially allows us to remove the part from the supports easily.
So real quick, like I said, I'm here in Boston at Desktop Metal. I've been here for the last week and finally got my hands on with this printer. And I have to say, I'm blown away. It's amazing to be able to create metal parts in an office environment where it's quiet and clean, and the parts can be of extreme complexity and they come out great. So I'm super excited. We're going to have our first printer delivered to Salt Lake City next week, and that's where a lot of your guys' prints are going to originate.
So the process, the printer itself is just 1/3 of our process. As I mentioned, we are utilizing MIM technologies and MIM materials, or metal injection molding materials. So our process starts with a CAD model that can be sent to our Fabricate software. Your native CAD file can be sent to the Fabricate cloud software, where we position We apply what materials. For the design contest, we're going to be using 17.4, but you would apply your materials there, and it automatically generates the supports and provides you build estimates, and you can actually watch the part printing from there as well. So you'll send the part from Fabricate, or we will, from GoEngineer or here at Desktop Metal, and it will go directly to the printer. It will automatically scale the part up to the appropriate sizes to accommodate for the shrinkage that we will experience in our sintering process. And then the next step is a debind process where we remove the primary binder from the parts, creating very small cavities throughout the model. And we then put that part into a furnace and we sinter it. And then you have your finished part that you can remove from the support structures.
And then once the part's removed, you have 100% metal part. There's no remaining polymer, and you can do all of your standard metal finishing touches, right? You can do some coatings, you can do some deburring or polishing or machining on the tightest tolerances, correct?
Correct.
Awesome.
So the material that we're going to be using for this competition is the 17.4 pH stainless steel. This is a precipitation hardening steel commonly used by aerospace, petroleum, chemical, and food processing industries. Its hardness and corrosion resistance makes it ideal for jigs and fixtures, brackets, as well as production parts, including gears, valves, and pump shafts.
Awesome. So I'm going to do a quick overview of the Fortis series machines. We just got a brand new Fortis 450 MC in our Salt Lake City office. It uses fused deposition modeling. That means engineering grade thermoplastic materials. The build volume is a little bit larger, so if the specific design process that you're trying to solve with this challenge doesn't fit in the envelope of the DM Studio system, then you might choose to use a high-performance plastic instead. The plastic that we are printing in is called Ultim 1010. It's the flagship material from Stratasys. It prints in only one Z resolution, that's 10,000ths of an inch. This machine is capable of printing as fine as 5,000ths of an inch, and as coarse as 13,000ths of an inch. It also, in general, creates support material out of water-soluble support or breakaway support, but specifically the material that we're using in this challenge, because it is the highest performing material, it is only breakaway support. So something to think about when you're submitting your designs. Ultim 1010, it's known for having the highest strength and stiffness in the FDM world. It is the most temperature resistant material offered in the FDM world. It is FAA certifiable for flight and food safe. We hear about production parts ending up on Boeing and Airbus aircraft. These are typically made out of this material. Some suitable applications would be some very high performing prototypes, composite tooling and other type of low cost rapid tooling, jigs and fixtures and brackets, and also low volume production parts. You can see the complexity of that part is pretty high, and those are the types of things that, we're hoping to see out of this challenge. So that's a quick introduction to the Generative Design Challenge. Really hoping to see a handful of you guys here on the live show submitting or registering for the event soon. And like I said, we expect to see a lot of interest in this event over the next couple months as we continue to promote it and fill out those updates. GoEngineer.com/design challenge. If you have questions about the design challenge at any time, you can shoot me an email, treat@goengineer.com. You can also reach us through the comments window in the landing page, or shoot any of us an email as well. And for those of you live, we're going to have a questions section here in a bit. But for those of you who are watching this later, thanks for joining and have fun.